All right, so today we'll be focusing on forecasting. It is week 4, and to get to the slideshow, you go to this course in Blackboard, click on Content, scroll down to week 4, forecasting. I want to remind everybody that the lecture will be posted either after this class or a couple days. It'll be posted before the end of the weekend. So if you want to review anything from the lecture, anything that was discussed, it'll be in this section in week 4. All right, we'll get to the slideshow. All right. So forecasting is a statement about a future value of a variable of interest. So an example of this would be something like an auto purchase. Buyers want vehicles, and most want it right away. They don't want to wait, you know, 3 months, 6 months. They want it over the next week or the next day or the next hour. If the car dealer they visit doesn't have what they want, they usually go on to the next dealership or go on to the next seller. So for a dealer, it's important that they anticipate what buyers want and and to have the models and the options and all the vehicles in stock. And to do this, the dealer will use some type of forecast or for sales to kind of guesstimate or anticipate what a buyer wants. There are two important aspects of forecasting. The first is the expected level of demand, and then the next one is the forecast accuracy, which the forecast accuracy is a function of the ability of a forecaster to correctly model demand and sometimes model unforeseen events. So forecasts are made with a reference of a specific time horizon or a specific time period. The time may be short term, something like an hour, a day, a week, or a month, or it may be longer, 6 months down the line, a year down the line, 3 years down the line, 5 years down the line. Short term forecasts are usually used for ongoing operations, while long term forecasts are used for strategic planning. When forecasting is used in the business, it's going to affect the decisions and activities throughout an organization. As you can see, the accounting department, forecasting is used in accounting. Forecasting is also used in finance when they have an expectation of available parts or equipment. If they forecast that maybe a couple months down the line when there's a shortage of things, maybe that the price of the materials or the equipment it might increase, that may cause the business to purchase more than not at a particular time. If they forecast down the line that something's not going to be available, or there's going to be an increase in demand, they want to have everything available, so they use forecasting for that. Human resources, that they forecast for how many people are going to be needed for a specific time. The U.S. Postal Service, they usually, once it comes time, like later on in the year, like November, December, Christmas time, they'll usually have seasonal hiring where they'll hire more people, so that because the amount of packaging and the amount of demand that goes into like shipping packaging and gifts and things like that during the Christmas holiday or the holidays, They may need more people, so they'll use forecasting. They know, for the past 30 years, 30, 35 years, right around November and December, the demand it increased. So you want to have enough people available to meet that demand. For marketing, they may expect a shift in demographics or a shift in you know people using a product depending on a particular season, a particular area. So they're going to forecast what's going to be demanded by the consumer, and they're going to, based off of that forecasting, the company is going to they're going to adjust accordingly. Accurate forecasts can help managers plan tactics like offering discounts at certain times, or not offering discounts. If you know that your demand is going to be high at a certain time, you may not want to offer a discount because you already know that people are going to be coming to use your service or use your product. So you might say, well, I already know the demand is going to be high. There's no need because people are going to be coming to the door. Now, if the demand wasn't as great, then they might want to add some discounts so that they get that foot traffic in the door. There are two uses of forecasting. First being plan for the system. These are generally long-term decisions, and it includes things like what type of products and services to provide, what facilities, um, the facility locations. The next one is plan the use of the system. These are generally short-term, so they want to figure out how much inventory we need to have, how many people we want in the workforce, how many people are we going to hire, what's going to be the budget, how are these people, when we do hire the people, what type of scheduling are we going to have. Forecasting is used to predict profits, revenues, costs, productivity, changes in prices and availability of materials, interest rates, and forecasting is used for a lot of different things. But we will mainly focus on demand in this chapter. So when we do some examples very shortly, we're just going to be specifically talking about demand, and we're not going to be talking about interest rates or profits or revenues or costs. We're going to be specifically concentrating on demand. Despite the use of computers and mathematical models, forecasting is not an exact science. So even though you have all of these mathematical models, you have all these equations that you have, it's not an exact and perfect. Um, it's not exact or perfect. In order to be successful at forecasting, it takes some skill, and then it also takes a little bit of guessing as well. Some of the features common to all forecasts, one of them being forecast, again, it's not perfect. Actual results usually differ from the values, the forecast values. So you must allow for forecast errors, which we'll talk about how errors are calculated when forecasting is used. Forecasts for groups of items are more accurate than those for individual items. So opportunities of grouping may occur if parts or raw materials are used for multiple products, or if a product or service is demanded by a number of independent sources. Forecast accuracy decreases as the forecasting horizon or time period increase. Short-term forecasts usually have fewer uncertainties. So they already know that, you know, certain variables are going to be there. Long term, on the other hand, it's not as there are a lot of uncertainties because you don't know what's going to happen from now to maybe a couple months down the line when you forecast what you're forecasting for. An example of this would be you know weather forecast. um, they get paid to be right certain amount of times. They use models and computer generated models, and most of the time they're pretty accurate, but there are other times where they're not accurate. Businesses that can respond quickly to the changes in demand require shorter time, and they benefit from more accurate short range forecasts than competitors. All right, so forecasts should be timely. Usually, a certain amount of time is needed to respond to information contained in the forecast. An example of this would be capacity that may need to be expanded overnight. Um, Forecasts should be accurate, and this enables users to plan for possible errors and provides a basis for comparing alternative forecasts. They should be reliable. It should work consistently. If it only provides a good forecast, some of the times, a poor forecast could leave users with an uneasy feeling. So if they see that you forecast something and it's only reliable some of the time, they might be kind of hesitant to believe whatever you're forecasting. So they might have some 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 feelings. They might catch feelings about that. It should have meaningful units for in the finance world or in finance terms. They use units of dollars. Schedulers use use machines and skills that's available. It should be in writing. It should provide objective basis for evaluating the forecast once actual results are in. It should be simple and easy. It should be simple to understand and simple to use. The simpler techniques are more popular because of the ease of use, which we'll see one of the simple ways of forecasting, which we'll get into that very shortly. They should be cost effective. So if it's costing a lot of money to come up with forecasts and it's a small benefit for it, 9 times out of 10, the company or the organization is not going to use that that forecast because it's costing too much and it's providing a small benefit for it. All right, some steps in the forecasting process. Determine the purpose of the forecast. How's the forecast going to be used? When is the forecast going to be needed? Amount of resources needed, and what's the level of accuracy we're trying to go for. Establish a time horizon or some type of time period. You need to know how long the forecast is. Is it going to be in days? Is it going to be hours, weeks, months? Accuracy decreases over time as the length of the forecast is. The accuracy will decrease. You want to get you want to have clean data and analyze appropriate data. So this helps eliminate junk results. Remember, bad data in is going to generate bad data coming out. So you want it to be clean and it has to be appropriate for what you're trying to forecast for. You want to monitor for forecast errors to determine if it's performing satisfactorily. If it isn't, then you're going to either need to re-examine the method you're using, or you want to know whether the data is valid. So if it's not coming up with the results or it's coming up with a lot of errors, then you need to find another method. You need to use another method to forecast if that's something that's beneficial to you and your company. So forecasting approaches, you have two. You have the qualitative forecasting, which it uses soft information. It's subjective. It requires human interaction and it brings in personal opinions. Since consumers generally determine demand, it seems obvious to get the consumer's input. And one way that it's done is by doing surveys. Now, I know that, Brian and Stratton has surveys that they ask. You know, Amazon has surveys. There's basically a lot of surveys. That's one reason that organizations give out surveys so that they can kind of get an ideal or get a sense of what their consumers or their customers want. All right, so the other forecasting approach is quantitative forecasting. That relies more on hard data. So remember the term bad data in, bad data out. So it's only as good as the quantitative forecasting is only as good as the data that it's using to come up with the forecasting. So time series forecasts, we're going to spend a decent amount of time on this. That's time ordered sequences of observation taken at regular time intervals. So again, the time intervals are going to be hourly, daily, weekly, monthly. The data may be in measurements of demand, which it's definitely going to be in demand for the examples that we do today. It could also be in sales, it could be in earnings, but it's going to be in some type of measurement that you're going to say, after we come up with these numbers, this is going to be the measurement that we use for that. All right, so we got a few that we'll discuss as far as behaviors, trend, long-term upward, downward shifts of data, population shifts. That's something like the the census that come out every 10 years. Kind of gives an idea of where people are living, if people are migrating to different places, if people are moving out of cities or moving into the suburbs. The census kind of gives that idea. Seasonality, short term, fairly regular variations, generally related to factors such as the calendar or time of day. Something like that would be, seasonality, demand would for like movie theaters where a lot of people go to movies and go to plays and things like that a lot more when the weather is a lot warmer. So up here in Northeast Ohio, generally people are going out to movie theaters and going to look at plays more in the summertime, the spring summertime, where in the wintertime it's not as busy. Same with restaurants. Restaurants have different times of the day where they're busy. They might not be as busy, from 11 p.m. If it's a 24-hour function, they might not be busy, from 11 p.m. till maybe 6 a.m. But from 6 a.m., till 10 p.m., 10:59 p.m. is really busy. Cycles are wave-like variations of more than 1 year. These are generally used to show economic conditions, political conditions, and also to keep track of agriculture. Irregular variations are due to unusual circumstances such as severe weather conditions, or if there's a work, a strike at your job, or a major change in a product or service. They don't reflect typical behavior. So once it's identified that this is an outlier, then that is generally removed or eliminated from the data so that the forecasting can be a little bit more accurate. All right, so this is one of the simplest types of time series forecasting, the naive forecast. It uses a single previous value of a time series as the basis for its forecast. These can be used with stable time series, seasonal variations, or trends. Some of the advantages to using this type of forecasting is it doesn't cost anything, or it's a very small cost to use it. Quick and easy to calculate, which we're going to see once we do some examples. It's easy to prepare, and it's very easy to understand. So what we're going to do now, we're going to use Microsoft Excel. We're not going to use any of the calculations or the functions to come up with them. We're actually going to do the calculations ourselves. Alright, so what you see now is our example that we're going to use to calculate, to do some forecasting. So the first, you see you have your period or amount of time that you're going to be doing the forecasting for. You have your actual amount, and then you'll have a change from the previous value. So for period 2, the change from period 1 is you subtract, you do 53 minus 50, and that equals 3. So that's where that plus 3 came from. And then you have your forecast amount. Alright, so we're going to start with period 3, and let's do some forecasting to try to figure out, period 4, period 5, period 6. So we say the actual demand is, let's say, 55 for period 3. So as you can see, you pretty much just take the forecast. In order to get the forecast, you're going to subtract the actual number from the previous period, or you're going to add the actual number from the previous period to whatever the change is from the previous period value. So that's how you calculate that. You will need to know how to do this for the current event assignment. Alright, so when we do time series forecasting and we actually want to do some averaging, there's 3 techniques that we're going to use. We're going to use the moving average, what you see here, the weighted moving average, which we'll do, and then the exponential smoothing. These techniques work best when a series tends to vary with average. So we're going to do an example for moving average, Microsoft Excel. We're going to use Excel for that, for the moving average. Alright, so to calculate a moving average, you would take the last 3 periods, the demand from the last 3 periods, you would add them all up, and then you would divide them by 3, because there's only 3 periods that we're using. So if we wanted to calculate period 6, so we'll do F6, or we'll make it P6 since we have periods. So that would be equal to 43 plus 40 plus 41. All of that is divided by 2. Let me put some parentheses around that. So if we add that up, so we got 43 plus 40 plus 41, and we divide it by 3, not 2. So the moving average for period 6 would be 41.3. We don't need to put all those 3's after that. So as you can see, the moving average is pretty simple. Once you get into a rhythm, you're just pretty much taking the last 3 periods, the values or the demand for the last 3 periods, adding those up, and then dividing by 3. Alright. So the second time series forecasting we'll be using, and you'll be using on your assignment, is called weighted moving average. With this, it takes the most recent values in the time series, and they're given a certain weight. So it will say, it's 40%. The weight is 40% or 30% for a particular period, and then it'll be 30% for the previous period. So there's going to be some type of weight that you're going to have to use to come up with the weighted moving average. So if we were calculating for period number 6, that would be equal to, well, as you can see below, we have a weight of 0.40 or 40% for the most recent, 30% for the next most recent, 20% for the next, and 10% for the next. So if we wanted to calculate it, we would go with the most recent, which is 41. We'll do 0.40 times 41 plus 0.30 times 40 plus 0.20 times 43 plus 10%, 10.10 times 40. And if we add all of those up, alright, so after adding up all the numbers, period 6 equals 41. We'll move on to the third time series forecasting averaging technique, and that's called exponential smoothing. Exponential smoothing is a weighted averaging method that is based on the previous forecast plus a percentage of the forecast error. So next forecast equals the previous forecast demand plus smoothing constant, which is all multiplied by actual previous demand minus previous forecast demand. So that's what this means in English. Exponential smoothing is a little bit more involved, so it takes a little bit more of working through. But just remember, if you want to use this equation, you can, or this equation, which is a little bit easier, where the next forecast equals the previous forecast demand plus the smoothing constant times actual previous demand minus the previous forecast demand. This is what this says in English. Alright, so when you're doing forecasting, you always want to figure out how accurate the forecasting is, and you want to give yourself an allowance, or some type of level that you're comfortable with as far as what the forecast comes out to be. It's important to provide an indication of the extent to which the forecast might deviate from the value of the variable that actually occurs. So to do that, you want to monitor your forecast and try to figure out what how accurate they are. And when you come up with a level that you're comfortable with, if errors fall beyond, whatever you set, then you're gonna have to figure out, ways to correct whatever the forecast is or whatever the problem is. So these are three different ways to do it. The first one being the mean absolute deviation. This pretty much is the average absolute forecast of the errors. The next one would be the mean squared errors. So this is the average of squared forecast errors. So you're going to multiply whatever this number is by 2. You're going to multiply it by itself. And then you have the mean absolute percent error. This is the average absolute percent error. So as with the previous few equations that we did, we're going to do an equation to figure out what the mean absolute deviation is, what the mean squared errors are, and then the mean absolute percent errors are. Is find out what the difference is between the forecast and the difference of the errors. So to do that, we're going to subtract the actual from the forecast to come up with the difference. So we have 107 minus 10. That would give us a -3. If we go to period 2, that's 125 minus 121. That'll give us 4. Alright, so after we find out what the differences is, we need to make those absolute so they all come out positive. So you have a 3, a 4, 3, 2, and 1. So that would give you your mean absolute deviation for each period. So for period 1, the mean absolute deviation is 3. For period 2, it's 4. For period 4, it's a positive number, 2. And then for period 5, it's also a positive number, which is 1. So after you come up with your mean absolute deviation, you need to get the sum of those numbers. So it would be 3 plus 4, which is 7. 7 plus 3, 10. 10 plus 2, 12. 12 plus 1. So the sum of that is 13. And since you have 5 periods, n equals 5. So to come up with that number, you are going to divide 13 divided by 5, which equals 2.6. So that's how you come up with the mean absolute deviation. You have to figure out what the differences are by subtracting actual minus forecast. You need to make all of those numbers an absolute value, and then you divide whatever the sum of those numbers are by the number of periods, which is 5, and then you come up with your 2.6. Alright, so after you multiply each one of the mean absolute deviations by themselves, you would come up with you would add all of those numbers up. So 9 plus 16 is 15. 15 plus 9 is 24. Or excuse me, 9 plus 16 is 25. 25 plus 9 is 34. 34 plus 4 is 38. 38 plus 1 equals 39. So that's the sum of those numbers. So as you did with the mean absolute deviation, you're going to add all of those numbers up like we did, but instead of using 5, you're going to subtract 1, which would give you 4, and after you get that number, you would divide 39 divided by 4. And 39 divided by 4 equals 9.75. Alright, so to find the mean absolute percent error, what you would use would be your mean absolute deviation. You take that number, you would divide that by the actual number, and then you will multiply all of that by 100. So if we did that, 3 divided by 107, and then multiply that by 100 to give us a percentage. So the percentage of that would be 2.8%. Alright, so after you calculate all of the mean absolute percent errors, you're going to come up with a sum. If you add 2.8 plus 3.2 plus 2.6 plus 1.7 plus 0.93, that gives us 11.23%. So that's the sum. And then you would use 5. So you would divide 11.23 divided by 5, and that should give you 2.25 if we round it up. So that's how you calculate the mean absolute deviation, which is the average absolute forecast of forecast errors. Mean squared errors, which is the average of squared forecast errors. And the mean absolute percent error, which is the average absolute percent error. Alright, terms for the quiz. First one is going to be control chart. Exponential smoothing. Forecast. Naive forecast. Time series forecast. And weighted average. Instead of control chart, let's do the Delphi method. So you can scratch out control chart and put Delphi method. So you should have 6 terms. Again, the terms are Delphi method, exponential smoothing, forecast, naive forecast, time series forecast, and weighted average. For the problems, you want to work on problem 1. You want to be able to do problem 1 and problem 2. And for the discussion and review questions, number 1, number 4, say number 7. Number 7. For the current event for week 4, everybody gets assigned a different size. So, Baha, you take small. Josh, you take large. Nate, you take extra large. Parker, you take medium. Heidi, you take extra large. And Charles, you take triple XL. So again, sorry about that confusion. Baha, you take small. Parker, you take medium. Josh, you take large. Heidi, you take extra large. Nathan, you take double XL. And Charles, you take triple XL. I need to mention for this project is there's only going to be expected to be 6 slides. Slide 7 is actually slide 6, so keep that in mind when you're doing your current event for this week. There should only be 6 slides, not 7.